So how would we count this? There we go. Find the number of poker hands with no clubs. Now, in any deck of cards, there's 13 of each suit, and there's 52 cards in total. So if 13 of them are clubs, that would leave 39 of them that are not clubs. One way to guarantee this is if you wanted to give out 5 cards, because a poker hand has 5 cards, and you wanted to make sure someone got no clubs, what you could do at the beginning is take out the clubs. Then you would only have 39 cards left, and you have to choose 5 of them. So if we would do 39, choose 5. Go to our calculator and type that in. It's a pretty looking number. 57, 57, 57. And that would count the number of hands. Remember, there was 2.6 million poker hands in total, about, and 575,757 of them have no clubs. Because what we did is we took the clubs out, then did 39, choose 5. Now, for part B here, what I'm going to do is we're going to now look at how many poker hands have at least one club. And I'm going to try to be like a salesperson. And I'm going to tell you 3 different strategies. And I'm going to present each strategy as this strategy makes sense and works. What you have to decide is whether or not all 3 strategies work that I explain, whether or not all 3 strategies are logically bad. Maybe there's something wrong with them. And so I'm going to explain 3 ways to do this one with at least one club. And then we'll talk about which ones are right and which ones are wrong, and we can figure out what went wrong in the wrong ones, if there are any, or what went right in the right ones, if there are any. Okay? So here is strategy number 1. I want at least one club. So what do, I go to my cards. I have 13 clubs, and I choose at least one club. So 13, choose 1. I take my 13 clubs, and I choose one of them. Now I need 4 more cards to make a hand of 5. I put the other 12 clubs back in the deck, shuffle it up, and I now have 51 cards left. And if I choose 4 more, can you see that I'll have at least one club guaranteed, but I could have more clubs, because in the 51 that I have, I could choose 4 more clubs, but I could choose different cards as well. So that's strategy number 1. That would give me at least one club. Strategy number 2. What I'm going to do is I'm going to count this as, in A, we counted how many didn't have any clubs. So I'm going to use the not strategy. The not strategy, again, is where we take all the possible ones, and sometimes it's easier to count the bad ones, and we subtract them. So all the possible poker hands in total, we already figured that out before, was 52, choose 5. And the bad ones would be all the ones with no clubs. If we take out all the hands with no clubs from all the possible hands, what would be left are ones that have at least one club. So we're going to subtract the 39, choose 5 that we had before. So that is a second way to come up with this. A third way is using cases. What I'm going to do with my cases is I'm going to count how many have 1 club, then I'm going to count how many have 2 clubs, then 3 clubs, then 4 clubs, then 5 clubs, and I'm going to add them all up, because if I add up all those separate cases, of exactly one club, exactly two clubs, and so on, then I should have all of them that have at least one club. So if I wanted one club, well, that would be 13 choose 1. And since my other card are not clubs, I have 39 other cards and I choose 4 of them. That'll be case 1. Case 2 would be 2 clubs. 13 choose 2 of them, because that'll get me exactly 2 clubs. And then from my other 39, choose 3 other cards. Case 3, and you can probably see there'll be 13 choose 3 clubs. Then from the other 39 cards, I have to choose 2 more. Case 4, 4 clubs. 13 choose 4 times 39 choose 1. And finally, case 5, 5 clubs, which is just 13 choose 5, and I don't have to choose any from the other 39 because I've already got my 5 cards. And if I add up all of my cases, that will be the total of at least 1 club. So now I've said 3 strategies. I hope I kept a good face during all of them. Did they all sound right? That was my plan. Are they all right? Or is there a problem with all of them? Or are they all wrong? Or is only one of them right? Has anyone calculated the first one out? So here's a problem that we noticed. $3,248,700. Do you see a problem with that number? It's more hands than we figured out. When we figured out all of them, we got about 2.6 million. I think it was 2598960. Another useless number to have memorized. That might, I don't know. You have to check back in your notes to see if that is, yes? Okay. So we've got about 2.6 million. However, when we count in the first way, we get more poker hands that have at least 1 club than all the poker hands that are possible. So that is also telling us that we've counted things too often. And what you guys pointed out was, yes, here we wrote one down with choosing the ace of clubs first. But then you could choose the 2 of clubs in the second part. But you've counted that one twice then, because you could have picked the 2 of clubs first and counted the ace of clubs after. Whenever you're doing, see here there's a problem because there's a little bit of overlap. You could choose the same card in those different spaces. So anytime you're counting things where order doesn't matter, as soon as you count them separately, you create a little bit of order within the question, because I'm choosing a club first and then 4 other cards. And if there's overlap, like we did here with the, you could choose clubs in either place, then you're going to find yourself over counting. Whereas in the cases question, I'm doing the same kind of thing, but can you see that there's no overlap? I'm choosing clubs first, and then I'm choosing not clubs. So then I don't have to worry about counting things twice there. So this one works. It is the right idea. And this one gives you the same amount as well. The middle strategy is the shortest. So this is a good example of where that not strategy, where if you can count the opposite of what you want, so having at least 1 club could be done in cases, but it's easier to count how many have no clubs and subtract it from all of them. And you get just about, what is it, just over 2 million hands have at least 1 club.